In this video, we'll look at what a difference amplifier, also known as a subtractor, is. We already know that an op-amp itself is a differential amplifier, which means it amplifies the difference between two input signals. However, due to the high value of gain, the output of the op-amp saturates even for a tiny differential input. To solve this issue, we keep the op-amp in negative feedback. Based on where we apply the input, we get two types of amplifiers, inverting and non-inverting. But what happens if we give an input to both the terminals? Suppose we apply an input V1 to the inverting terminal via a resistor R1, and a feedback resistor R2. Similarly, let's apply an input V2 to the non-inverting terminal via resistors R3 and R4 as shown. We can find V out very easily by using the superposition principle. First, we find the effect on V out as if V1 were acting alone. We follow the same procedure for V2 and add up the two to give us the actual value of V out. If we switch off V2, the circuit reduces to the inverting amplifier configuration. Note that the non-inverting terminal V+ will be 0 as no current flows through resistors R3 and R4. Hence, using the inverting op-amp formula, V out due to V1 is equal to minus R2 upon R1 into V1. Now, we'll switch off V1 and switch on V2. The circuit reduces to the non-inverting amplifier configuration. R3 and R4 form a resistor divider, hence the value of V+ will be R4, upon R3 plus R4, into V2. Using the formula for the non-inverting amplifier, V out due to V2 is 1 plus R2 upon R1, into R4 upon R3 plus R4, into V2. Adding the individual contributions due to V1 and V2, we get the following equation. As you can see, V1 is being subtracted from V2 in a weighted manner along with a gain. To achieve pure subtraction, all we need to do is choose the values of resistors such that R2 upon R1 is equal to R4 upon R3. That leaves us with R2 upon R1, into V2 minus V1. This gives us subtraction with a gain. Further, if we choose the same value for R1 and R2, we are just left with V2 minus V1, the straight difference between the two inputs. Thus, using an op-amp we have created a subtractor circuit. That's it for this video. If you have any questions, feel free to ask in the comments section. Don't forget to like, share and subscribe.